Hello. Um, so in this video I will be discussing the long division of polynomials, which is material to learn especially for pre-calculus and college algebra. Long division of polynomials is pretty easy and easy to learn once you just understand the material. Basically, it's not one of the difficult aspects of pre-calculus. It could have been it's way easier than matrices and polar coordinates and such. It's one of those ones in chapter 2, I believe, section 2.3 in certain textbooks, that you'll learn about the long division of polynomials. It's pretty important, especially to find the zeros of polynomials. So anyway, without further ado, I would like to show an example in order to demonstrate how it's done properly. So let's say we have 2x squared plus 10x plus 12, and we want it divided by x plus 3. Pretty simple. I mean, sometimes you can actually factor certain things and you'll get the same answer, but this is more of a concrete way to get that answer. So I'm going to start out like this and draw this. This is how we do it. I'm going to put this into this area. There are always mathematical terms for these things, like dividend and all that, but I don't feel like saying any of that. I'll just say this thingy, so that's what everyone can understand. And then I'm going to place that over there, so like x plus 3 is right here. Anyway, so what I'm going to start out doing is there's 2x squared. I'm going to think, well, 2x squared divided by x, what's that? That's 2x. So 2x goes up here. I take this 2x up here. I times it into this x plus 3. So 2x times x is 2x squared, right? And then 2x times 3, well, that's just 6x. So plus 6x. And if this was more than a binomial, this expression, then I would have to use all 3 of these inside, but I only really need to use 2 because x plus 3 is a binomial. 2 terms. So, and then what I want to do is subtract this from this, and this will cancel out. And your objective is to get this to cancel out ultimately. So you would have to times it back in. And, well, 10 minus 6, that's just 4x. So now I have the 4x down here. I think to myself, divide it by x again is going to be plus 4 up here, which means that I plug that back in again, which is 4x subtract. But then I have 12 up here, and I can just like drag that like that, so like plus 12. And then 4 times, oh, this is really good, plus 12. This means that this will cancel out with this. It's going to equal 0. And this is going to cancel with this, which means that we have no remainder. So all it was is 2x plus 4. And that's your answer. But now I would like to show what happens when we do have a remainder and how to demonstrate that. That would be like if I did 7x plus 3 divided by x plus 2, and I set it up the same way. 7x plus 3 is in here like usual, and x plus 2 is over here. So I'm going to think, well, 7x divided by x, that's just 7, right? And I'm going to plug that back in, so 7x is going to be, and then subtract, and then 7 times 2, now that's going to be positive 14, and we have an issue over here. These will cancel, but this becomes, I think that's negative 11, and that is a remainder because we can't do anything further with that. So we can just say r is that, and you can circle this, and that's how you can represent it, except I prefer an alternative way. You can say 7 minus 11 over x plus 2 is a better way, more clear. I would like to do one more example of this, and then we're going to go to synthetic division, which is more fun. 5x squared minus 17x minus 12 divided by x minus 4. Okay, set up the same way. So 5x squared is in here, minus 17x minus 12, x minus 4 is over here. So I think to myself first, 5x squared divided by x, what's that? Well, just 5x, right? So 5x, and then I plug that back in, and I'm timesing 5x by x minus 4. That's 5x squared, and then it would be negative 20x, and these would cancel, and I'm left with, well, 3x. So 3x divided by x is 3, so plus 3, and now I times this by that. 3, I'm timesing it back into the x minus 4, like usual. 3x, well, it would be 3x over down here, but we drag this down first, and that would be the negative 12. But then this 3 and negative 4, 3 times negative 4, that's what, negative 12? And negative 12, these cancel, and these cancel. Remainder of 0 again. That was a great one. Just came out perfect. So the answer is 5x plus 3. Okay, that's enough of that, because that can just be simple. If you think about it logically, you just times it by the first thing. You divide it by the first thing, and then you go on from there, and you just think, well, 5x squared divided by x, that goes up there, and then I plug that back in, and I keep doing that over and over while subtracting these and making sure that this cancels out over here. Okay. Now, synthetic division. Synthetic division is a more fun and shortcut way of division. You can't use it when something is when you're dividing into quadratic or higher degrees. But let me show you an example. 3x to the third minus 17x squared plus 15x minus 25 divided by x minus 5. Okay. So we couldn't have it if we couldn't do it if we had this x over here. If this x to the first was an x squared or higher, we couldn't do it. But luckily we just had that, so we can use this shortcut method. It's alternatively called. We set up. Oh, that's not good. Erase that. Give it more room at the bottom. There we go. So I'm going to take the opposite sign of what this x minus 5 is. I'm going to take the opposite sign of that 5. Right now the 5 has a negative sign, so I'm going to make it positive because it's opposite. So 5 is up here now. Then I put 3, negative 17, this is part of the setup, and negative 25. Okay, what do I do first? I take this first number over here, and if you remember this, then you can sort of figure out what you have to do. I take this first number, this 3. It's always the a, the first term, first coefficient. You just drag it in, down there, straight down, 3. And then I want to times that by 5. Whenever you're going vertical, up and down, you are adding. Whenever you are going diagonal, sideways like this, I'm about to do, you times by the 5. So 3 times 5 is 15. And then I'm adding. So negative 17 plus 15 is equal to negative 2. And I do this same thing with this negative 2. And I go negative 2 times 5 is equal to negative 10. So 15 plus negative 10 is equal to 5. And then I times it again. 5 times 5 is 25. Oh, look. we have a cancel out over here, which means that this is 0. This term, this last term of the bottom, is always a remainder. It's the remainder. So we have no remainder. But this means that the answer is 3x squared minus 2x plus 5. And that is the answer for synthetic division there. That is all I will do for now. If you have any questions about long division and synthetic division, please ask. Feel free to comment and subscribe.